I'm Aaron Hirsch with Triathlete.com. I'm here at the LA Velodrome to get a sneak look at the Track Aero System, an exciting new aerodynamic testing technology from ERO Sports. This tool allows a rider to monitor their aerodynamic drag as they ride around a velodrome, and possibly out on the road as well with another piece of hardware. By conducting the testing on a bike as opposed to in a wind tunnel, it's replicating real road conditions perhaps more accurately than even a wind tunnel. The device itself is mainly a software program that connects power data and speed data from the rider's bike and uses a complicated algorithm to produce aerodynamic drag using that information. The rider takes laps around the track and the system is constantly recording their data. By measuring information while they're making subtle changes either to position or equipment, the Track Aero system is able to quantify the changes in a rider's aerodynamics with each of these variables. Andy Franchione, the engineer behind the system, tells us a little more about the detail that goes into these measurements.
Well, what we're looking for is to measure an athlete's aerodynamic drag area, which gives you an idea of how efficient you are going through the air. And so by giving the positioning coach some feedback about the aerodynamic drag area, we're helping the athlete find the most aerodynamically efficient position. You show up at the track, you've got your bike, you have a power meter and a speed sensor on it. If you don't, we'll provide you with the appropriate equipment. Then you go for your positioning, whatever that may be, and the positioning coach, Jim, will set you up with something called a run list. So these are candidate positions that will be tested. You would need to be weighed, and the air density of the track is measured on that day. And then they give you one of these. So it's on right now. It's called a bridge. And the bridge basically is something that takes all the ANT data and it simply sends it to a Wi-Fi port. And so that allows our data collection equipment to begin accepting the data and processing it. And then from there, based on the run list, you would just do some laps. We're looking at the screen, we're looking at the drag area go up or down on a lap-by-lap basis, and we're forming conclusions even at that stage about what maybe another position might be, or a posture. It could be a shrug, it could be a change in hand position, and we're noting that down for future runs.
Zip design engineers Michael Hall and Dave Morris are also using this technology to help validate their product development information. They're going to tell us a little bit about how they use the system primarily outside in order to maximize the accuracy of the information they use to develop the next wheels and bars.
So what we're using is a little bit different from what you see here on the track. We're using a third component, which is the aero stick. So what we're using it for is to measure actual velocity, and that's relative to wind angle. So we're able to get accurate velocities at various wind angles, so we can simulate what we do in the wind tunnel, but out in the real world.
And Dave, why is it useful to use this system to conduct aerodynamic testing out on the road as opposed to wind tunnel testing?
So the Alpha Mantis technology with the aero stick and their track software is on a slider scale of a way you can test parameters on the bike, or test a cyclist on a bike. On the one end you have CFD, where you are you're simulating everything, and you're taking a lot of variables and you're taking your best guess and you're calculating a lot of stuff. Towards the other end of the spectrum you have this aero stick and the Alpha Mantis technology, where instead of estimating everything, you're actually measuring all those variables, and it gives you a much closer representation of what's happening in the real world. So there's a lot of dynamic interactions that are going on between the rider and the bike that you just really can't account for in CFD or in the wind tunnel.
Jim Manton is a bike fitter who's a key part of this whole equation, helping riders find a position that's not only aerodynamically efficient, but is also sustainable on the road.
Well, the first thing we want to know before we actually do any kind of aerodynamic testing is what are the biomechanical limitations that our client has. So we bring them into our fit studio, get a capture using our retool motion capture system, and that way we're able to identify what, if any, biomechanical limitations we have. We're able to know what changes we can try down on the track to optimize you aerodynamically without putting you in a position that just isn't sustainable. So for instance, we're testing on the track for 30 minutes. Is that a sustainable position over the distance, over an Ironman distance? So we can bring them back up into the studio, make sure we haven't taken them too far, and if we feel like we have, we'll make those slight adjustments for them.
A 2-hour fit with the Track Aero system costs $800 at the LA Velodrome. The system is already gaining acceptance with manufacturers and athletes alike. It has the potential to become the next major advancement in aerodynamic testing and cycling. I'm Aaron Hirsch with Triathlete.com.